So for this example, we want to give the first four terms of the sequence defined by the general term an equals n plus 2 over n cubed. Well, to do this, if we're given that definition an, all we really need to do is just plug in the first four values of n, where presumably n starts at 1. It doesn't necessarily need to. There's no hard and fast rule that says, well, it must start at 1, but usually that's where we have it go. Anyway, for this, if we want to find our first four values, then we would just take n equals 1, n equals 2, n equals 3, and n equals 4. That is, we look at a1, a2, a3, and a4. Where at a1, we are saying n is equal to 1. So we have 1 plus 2 over 1 cubed, which is just going to end up being three. Similarly, at a2, we are going to have 2 plus 2 over 2 cubed, which here that's 4 over 8, which is, well, 4 over 8, or 1/2. I'll say that the book generally wants these things in a simplified form. Personally, I think leaving them non-simplified is a bit more instructive to what we're trying to do in terms of identifying a pattern. This stuff's all about pattern recognition and manipulation, but, well, the book overrides me on this one. So you'd probably want to write that as 1/2. Anyway, for a3, hopefully we're starting to get the sense of what happens here. We take 3 plus 2 over 3 cubed, which here, that one doesn't simplify. We just get 5 over 27. And then finally, for a4, we would get 4 plus 2 over 4 cubed, which in this case is 6 over 64, and that simplifies down to 3 over 32. Where there are some characterizations we can have for a sequence that the book doesn't get into in very much detail, but I think are worth mentioning here. That we say a sequence is decreasing if its terms are going down, and technically speaking, we've only seen the first few of them. This could turn around somewhere. There are more exacting ways to check if a sequence is decreasing, but for us in this case, it looks like there's a good idea that this should be decreasing. We would say it's increasing if it goes in the other direction, and more broadly call something monotone if it's only going in one way or the other. Or more specifically, it doesn't do both. Technically speaking, a sequence that's always the same, the sequence of ones, is monotone because it's not both increasing and decreasing, it is neither, technically. Anyway, this is how we would handle one type of sequence. Let's get one more here before we move on. So for our second example, we want to find the first four terms of the sequence defined by an equals -3/2 raised to the power n. Do the same thing. So at n equals 1, we would get a1, which here would have form -3/2 to the first power, or, well, -3/2. For a2, we would just take that -3/2 and now raise it to the second power, which here would be 9 over 4, because you'd have that -1 squared, the 3 squared, and the 2 squared. Then at 3, we get a3, which is just that same type of thing, -3/2 now cubed. And, well, if you're going to cube a 3, you'd get 27. If you cube a 2, you'd get 8. And if you cube a -1, you still have a -1. So you get -27 over 8. And then we have a 4, which would be that same type of pattern. Oh, very exciting, isn't it? We would get 81 over 16, where a couple different things might start coming to mind here. For one, you might look at this and say, well, hey, it looks like we're just taking each of these things and applying the same thing before to the last one. And yes, that is the case. This hints at a thing called recursion that we'll see later. We can also see that these terms, they bounce between being positive and negative. Another one of those types of terminology that doesn't come up in the book here, but that is worth knowing, is that we call sequences of that form alternating, because they alternate between being positive and negative. And then also, we can call this a geometric sequence because this is defined by a common ratio, in this case, that common ratio being -3/2. But that's a definition we'll see more of in section 10.3, so a little while from now. And before we get to that idea of recursion, I want to take one more thing here with our next video to just talk a little bit about this setup for what a sequence is.